this computer. There we go. All right, so any other questions from our homework that we were unsure about?
Can we look at 5 as well on that page?
Yeah, we can look at number 5. Number 5, both of them are reciprocal identities, so I would go ahead and start with flipping both of them. It's going to be another case of what we've just seen where it's not real familiar to us to begin with. So when I flip the secant and becomes cosine, if I flip root 2, what does it become? 1 over root 2, right? Not something that I see for cosine in my chart, but I do know how to rationalize that. If I multiply by root 2 top and bottom, I get where's cosine equal to root 2 over 2. Then I flip the second one, cosecant becomes sine. And I already know now the rationalization for this one. So if I flip this, I don't really have to work through that again. I can just say this means then sine is negative root 2 over 2. So my question is asking me, where is cosine equal to positive root 2 over 2 and sine is equal to negative root 2 over 2 at the same time? So first off, the closest thing to that in my chart is at what radian? I don't have any negatives in my chart, but I do have cosine's positive root 2 over 2 and sine's positive root 2 over 2 at what reference angle?
Pi over 4.
Pi over 4. Okay, so then I know my answer is going to be a pi over 4 because of that reference angle, but I also know that at pi over 4 in the first quadrant, cosine and sine are both positive. So I'm thinking about in which quadrant would cosine be positive and sine be negative at the same time. So in second quadrant, cosine is negative, sine is positive. So it can't be second quadrant.
Third quadrant.
In third quadrant, what's true about both of them? They're both
negative. So
negative. Third quadrant. So it has to be in fourth quadrant, the pi over 4 reference angle. Anyone remember what the pi over 4 reference angle is in quadrant 4?
315 or 7 pi over 4.
7 pi over 4. Good. Or 315 in degrees. Okay. Any other homework questions? Or we feel decent about this right now? Getting there? The good thing is that I'm going to say similar to proofs, but not like we're doing proofs again, because I know some of you were like breathing a breath of relief that this is over. Similar to proofs though, this really just kind of builds on itself with a few more tricks over the next 2 days. This is a very short unit here. Really, there's only 3 lessons in it. So planning ahead for your next 2 weeks, just so, I mean, I know it's all on my PCA, but just talking through it. We have a live lesson today and then Thursday. That's our last new material for this solving unit. So next Monday, I'll run a review session, any questions that we have, talk about the test, so forth. The test is going to be scheduled because of A-Day, B-Day on Wednesday and Thursday. Since there's really no church right now on Wednesday, they told us we can schedule on Thursday, but we have to give you an option to do it another day. So B-Day can choose to take it on Thursday or they can choose to take it on Wednesday. That will be up to them. So that's what we're going to do for the next couple things. And then we are going to start unit 9, I think, limits. So we're going to get, this is officially the end of the dual credit material for those in dual credit. I got to look at my calendar. We're not losing the same kind of days that we lost like in class for AP testing and this and that and the other thing. I do think I'm going to have to move around some lessons due to AP testing coming up in May, or give you like extra time to do stuff, because if you're testing those days, it's hard to do all of school too. But yeah, so we're moving right along here. That's the plan right now. So we will begin unit 9 at the end of next week and keep pushing forward. Hopefully then when we get, if we get back to school, we can talk about stuff and wrap up life for the end of the semester. But we shall see what they all decide. So I don't really know. I'm just trying to be flexible. Oh, also survey for my friends on here that I have right now. I know the proofs test kind of stressed us out because of like the number of questions and what that meant for like number of questions. We've tried to like shorten stuff so that you're not spending forever on a computer for tests and quizzes. I'm writing the quiz for Thursday, Friday for y'all. Would we prefer it to be like 10 questions, even if it takes a little longer? Or we don't care?
We have more time to do it.
Yeah, if I do 10 questions. So here's what I'm working out. With all the let's look up stuff on the internet and share stuff with other people, and I'm not saying y'all are doing that, I'm just saying it is happening. Unfortunately, I've had a couple people that their answers were like exactly the same, and that's frustrating. I'm trying a new, like, rather than being like one printed out sheet, I'm trying to like make this in a quiz format in Canvas. But it's going to, like, I have like question banks, so it will select one out of a couple. So technically, like, most people will have different looking quizzes because they're going to lock up after each question, and you'll upload your work for each question one at a time. So I would give more time for that. But that also allows me to just put a time limit on a quiz without saying you must take it between these hours. So that I can say you can take it anytime on Thursday or Friday, but you're limited, like it shuts down after 45 minutes or an hour or whatever I decide to make the time limit. So that's kind of my new method that I'm trying. It may backfire on me, but we're going to try it on the quiz. The test, it was, I don't know. It was interesting. So I just keep trying to try new things, try to make things work for us. I'm not putting stuff on Lockdown Browser right now because that's just crapping out on all of us. And it shuts down on everyone. And let's be honest, if it's on Lockdown Browser, but you have a phone or a tablet at home or a home computer, it doesn't matter if I put it on Lockdown Browser. So, so that's my method to my madness on that one. So that's kind of what it looks like, or the quiz is going to look like. So yes, we'd prefer more questions if we have more time so that the points aren't so rough.
Yes, ma'am.
That's kind of the theory. Okay. If anyone has an opinion, just let me know. I usually try to ask the people that are not going to like tell me random stuff. So those that sign on and care right now, you're getting to input your opinion. Anyway, so notes today are not going to be super long. We're going to be on page, never have I been so grateful for this notebook, 245. This means I literally don't have to make everyone print out everything all the time. It's wonderful. So here's where kind of proofs come together with solving and with your chart. So we are going to still use our trig identities and stuff. It's just not going to be in the same way, in the same depth that we use them in proofs. It's kind of to a lesser extent. So today you will see our factoring is going to be like the theme of the day here. So we're going to start off somewhat easier and then jump into a couple that are a little bit harder. Really, I think we're going to go through page 247. So I have about like 7 questions and that's it. And we will be done for the day. So just like we saw in some of our proofs, you can factor trig equations. So what you're seeing here in question 1, hopefully we are recognizing this format here to be something like this that we know how to factor already. So using that basic setup, I can jump immediately in question 1 and factor this as a trinomial. If it's 2 sine squared, how are we going to split that up for the first terms?
2y and y.
Yeah, it's like 2y and y. And really, honestly, like if you are uncomfortable factoring this, you may always write it in that form to factor it and then just sub in the signs later. I'd like you, especially if you're going to do calculus, to get comfortable with factoring with the signs in it. So I would factor that into 2 sine and sine, just like I would factor this into 2y and y. Then I would look at the factors of 1 and say, combined with that 2, the factors of 1 really are just 1 and 1. Because the middle term is negative, I still use that as both of those are negative, and we would check. 2 times -1 is -2. 1 times the number in front of this one is 1, is -1. Does that add up to the -3 in the middle? Well, yes, it does, right? So it's just like normal factoring, only with signs in it. And just like normal factoring, how do we get to an answer from these?
Equal
Set
to
it equal to
0.
0.
Yep, we set both of our factors equal to 0. So 2 sine -1 equals 0, and sine -1 equals 0. Here's where I kind of skip that step. This starts to get to the place that some of us are more comfortable. I would immediately be able to jump down to this means sine is equal to 1/2, and this means sine is equal to 1. Something that you may not remember from factoring is that this right here is an or statement, not an and. And I make that distinction because a lot of these are going to have 2 signs in them. So you would get a whole lot of no solutions if you think about them as an and. But that's how these work. This factor has to equal 0, or that factor has to equal 0 in order for our answer to be 0, not both at the same time. So that means I can have multiple answers. So kind of going through my thought process, I would figure out, because even though I have what sine is equal to right now, this is not my final answer. My final answer is what radian does this happen at? So my first question to myself in order to get my answers for x is, where is sine equal to 1/2? And secondly, how many places is that going to happen? Sine's going to be equal to 1/2, 2 different places, right? So first answer I'm going to get directly out of my chart because this is a positive value for sine. So my first answer is going to be in the first quadrant, right? So where's my first radian answer for where is sine equal to 1/2?
Pi/6.
Pi/6. And then you don't have to draw these quadrant diagrams if you don't need to. This is just kind of, I'm trying to show you, since I'm not there, right there with you, my mental thought process. So my mental thought is sine's equal to 1/2 at pi/6. Sine's associated with y values, so it's also going to be over in the second quadrant, equal to 1/2. So what is the pi/6 angle in quadrant 2?
5 pi/6.
5 pi/6. So that's my second answer. If I've exhausted this particular solution, then I move on to the second one. So there's only 2 places because sine is going to be negative in quadrant 3 and 4. I've exhausted that one. I move on to where is sine equal to 1. Do we see that anywhere in our chart?
Pi/2.
Pi/2. I do a mental check. The other angle that goes with pi/2 is 3 pi/2. Is sine going to be positive there?
No.
No, it's going to be -1 there. So I'm not going to include that one. So notice in this particular question, I had 2 solutions for the first part, but only 1 for the second part for a total of 3. There's not going to be any rule of thumb for this. Like, some people always want to know, are you for sure going to get 2 answers for each one? No, there's no way to do that. It's knowing your unit circle and your chart. So there's 3 total answers for this particular question. Sometimes there's going to be 4, sometimes there's going to be 6, sometimes there's going to be 1, sometimes none. And that's just how it works. Okay? Any issues or questions with where those answers came from? All right, let's take a look at question 2. Given that today is factoring day, okay, one thing that we should remember is that in order to factor anything at all, what does it have to equal?
0.
0. So what does that mean I'm going to have to do in this particular question?
Make one side 0.
Make one side 0. You're going to have to move something from one side to the other. I emphasize this not because I think you guys are like dumb or anything, but don't divide by cosine, okay? Here's what's happening if you divide by cosine. If I divide by cosine, I am getting rid of an algebraic function in this problem, and I am going to lose answers. Now, what you may see later is that we're not going to get answers from that particular term. It sometimes happens that way, and it sometimes doesn't. So you could divide by cosine and get lucky in that those might not stay as answers. but don't bank on that. That's not proper algebra here. So which of these two terms do we want to move? It doesn't matter. Let's stick with our comfort level and move that term to the left. That's tends to be where we're comfortable. How do I move that term to the left?
Subtract it.
Fraction, right? So even though there's sines and cosines and all of this involved, this is still our basic algebra. If you want to move one term to the other side, you've got to subtract it. So that is an entire term altogether. It stays attached. You may not separate them. That's where we're at right now with equal to 0. Now, when we are factoring, whenever we factor these kind of things, we always have to look for what first?
Something to pull out.
Okay, greatest common factor. We always, always, always look for that first. That applies in trig too. So if I'm looking at these two terms, what is my greatest common factor?
Cosine?
Cosine. I'm going to take that and I'm going to pull it out. In the first term, I'm going to be left with 2 sine of x. In the second term, I'm just going to be left with what?
Square root of 2.
Root 2. Now, just like other times when we factor, we solve by setting our factors equal to 0, including the greatest common factor. So I'm going to go ahead and take my cosine, and I'm going to set it equal to 0 because I'm going to get answers from that. So this is what I meant by if you divide that cosine out, you're going to lose all these answers from cosine being equal to 0. My second factor, I'm also going to set equal to 0. And again, you don't have to show your solving work on this part if you don't want to. If you can understand, you're going to add the root 2 to the right and then divide by 2. Okay, you're going to get an answer like that, and you don't have to show the work in the in-between. If you want to, you're more than welcome to. But that, I am fully confident that you guys can solve those without doing every single step of adding and dividing. When you get to this place right here, you should feel confident because these are going to be all answers out of your chart, and these should be things that you start to recognize. So just like the last one, we're going to work through our answers one at a time. My first question for my answers for x is where is cosine equal to 0? In my chart, and then thinking where else. So first, chart. Where is cosine equal to 0?
Pi over 2.
Pi over 2. Think logically about pi over 2. One other angle goes with pi over 2, and that is what?
3 pi over 2.
3 pi over 2. Is it possible that cosine will also be 0 at 3 pi over 2? Yes. So I am going to include 3 pi over 2 for this one. Notice it was different for cosine being 0 than it was for sine being 1. Cosine being 0 cannot change sine, so it is equal to 0 at both pi over 2 and 3 pi over 2. Sine, where it was 1, changed signs. So you have to think about it differently. My second question, before I move on from that one, is there any other place that cosine could equal 0? They have to be the same reference angle. So if it's at pi over 2, the only other thing that goes with that is 3 pi over 2, and then you've exhausted that. You can't do any more. So I move on to my sine is equal to root 2 over 2. My first question to myself is, where is that going to happen for the first time?
Over 4.
Pi over 4. And if it's pi over 4, all of my other answers for that particular part of the problem is also going to be a pi over 4. So my only other options are 3 pi over 4, 5 pi over 4, and 7 pi over 4. But where is sine going to be positive? Which one of those?
3 pi
At
over
3 pi over 4.
3 pi over 4. In my mind, I'm saying in quadrant 3 and 4, it's going to be negative, so I'm not going to include it. So first question had 3 answers. This one has 4. It's going to be different every time. Okay? Questions about this one? This is where we're going to get super comfortable with your chart again, with the unit circle, and either you're going to get comfortable or it's just going to be right over your head. Because here's the thing. If you plug all this, like obviously I can't control calculator, non-calculator at home, but anyone know what's going to happen if I type these things into my calculator to get an answer? If I do inverse cosine at 0,
Give you a decimal.
I get decimals, right? So this is like the ultimate, I don't even have to be there. If you used a calculator, it's going to be obvious. You know, because there's no way you can get your calculator to change that decimal into the correct pi. It doesn't work that way. So you're going to have to find these answers using your chart and your unit circle yourself. There's no other way around that. All right. I want to do 3. I'm going to just run through these pretty quickly, 3 and 4, before we hit a couple more where we do have to use identities. 3 has one particular thing in it that really matters to us. And it always comes up if you haven't watched the video and haven't actually gone through this later, it will come up because it's going to come up on a quiz or a test. I would handle 3 just like I handled question 1. Cosine squared is going to factor into cosine and cosine. What factors of 5 are going to add up to 6 in the middle?
5 and 1.
5 and 1. Just like before, once we get this factored, we set our factors equal to 0. Again, if you skip right to where cosine is equal to the numbers, totally fine. I get cosine is equal to -5, and I get cosine is equal to -1. If I am looking at those answers, this is non-calculator. This is where I'm going to use my chart. What kind of alarm bells are going off in your head right now? Anyone have any?
5 on the chart.
Yeah, where the heck is 5 on your chart? It's not. Okay. Does this mean I have to use a calculator for that answer and not for the other one? No, it doesn't. And this is where we really start to pull like everything together from the semester. I'm going to throw something at you right now that you're going to be like, oh my gosh, I can't remember these things. Anyone remember the parent function graph of cosine? Looked something like this.
No.
X's and mins to that. How high did it go? What was the highest y value it touched?
1.
1. And what was the lowest y value it touched?
-1.
Yeah,
What does that tell me about that?
not real.
Can't happen.
Not real. Even if you had a calculator, you would not get solutions for that particular part of our question. I emphasize part of our question because just because I don't get answers for that does not mean that I immediately write no solution. Can I still get answers for this?
Yes.
Yes, I can. So my question is, first off in the chart, do I have cosine equaling -1 anywhere? I don't have -1, but I do have
+1.
+1. Cosine's equal to +1 where?
0.
At 0. Okay, so think in our heads, if cosine's +1 to the right over at 0, where is cosine going to be -1?
180.
20.
Pi.
All the way on the left at pi. Is there going to be any other place that cosine equals -1? The only things that go with 0 are 0 on the other side at pi, and then back to 2 pi where it's going to be the same as it was at 0. So is there any other place that cosine can be -1?
No.
Nope. So I like this question for 2 reasons. One is this throwing out the -5 thing because we know our parent functions right here and we know cosine only goes to 1 and -1. We can't have answers outside of that. Now that's only true for cosine and sine, right? Can we have answers outside of 1 and -1 for tangent and cotangent? Because if you remember the tangent one, that was this guy, right? So we can have answers outside of 1 and -1 for tangent. What about secant and cosecant? Remember what those looked like? These ones? The U's? Secant and cosecant will not have answers in between 1 and -1, but they will have answers outside of that. So, but we're not going to worry so much about the reciprocal ones because we're going to convert those all into the originals. So really, we need to have a good handle on where we can have answers for sine, cosine, and tangent. Okay. 4 is very similar to question number 2 that we did already. It's already equal to 0. It is squared, but that's okay. What do we always look for first, just as a reminder? Greatest common factor. What greatest common factor do I have in those 2 terms?
Cotangent.
Cotangent squared. I'm going to pull a cotangent squared out of both terms. And when I do that, what's going to be left in the first term?
1.
1
Okay. Yeah.
Minus what?
cosine squared.
Cosine squared. Now, some of you are immediately, your brains have already gone somewhere when you see this.
Yeah.
Where have we gone with that?
Is that a sine squared?
That is a sine squared. Now, do I have to change that to a sine squared in order to solve this?
Mhm.
Probably not.
No, I don't actually. If I set that factor equal to 0, I can get an answer for cosine squared. Now, here's the big thing that you do have to remember. If I change that to a sine squared, or if I solve that 1 minus cosine squared by setting it equal to 0, both times you're going to get the same answers. Okay? So let me just show you that. If I change it to a sine squared, it's still going to get set equal to 0. And if I square root both sides, we're looking for where sine is equal to 0. If I don't change it to a sine squared, I'm going to say 1 minus cosine squared is equal to 0. That's going to give me 1 equals cosine squared when I move the cosine squared to the other side. And when I square root, I'm going to get cosine is equal to what?
Positive, negative 1.
Positive and negative 1. So first, let's think about where is sine equal to 0. Go to your chart. Sine's equal to 0 at
0.
0.
Therefore, where else based off of reference angles?
Pi.
Pi, because sine is 0 here at 0. It's also going to be 0 over at pi. Now, we're not going to include 2 pi because 2 pi is essentially the same as 0. Now, think about this one. Where is cosine equal to either positive or negative 1? Cosine's equal to 1 over at 0. Where's cosine equal to negative 1?
Pi.
Pi. See how we get the same answers no matter what? Now, what have I not solved yet?
Cotangent.
The greatest common factor. Cotangent squared is equal to 0. With all 3 of the reciprocals, our first move is to flip this. So cotangent squared, if cotangent is equal to 0, what is tangent equal to?
Undefined.
Undefined. Okay, you might want to maybe solve the cotangent one first because we don't like square rooting undefined. It doesn't really matter because if I square root the cotangent and then flip it, I still get tangent is undefined. Okay, now that, even though it's undefined, does not mean that we don't have an answer from it. Because do you see tangent being undefined in your chart?
Yes.
Pi over 2.
It's at pi over 2. And because undefined cannot change signs, where else do we see cotangent being or tangent being undefined?
3 pi over 2.
3 pi over 2. Good. Perfect. Any questions about how this is going? Once you kind of get into the rhythm of finding the answers from these, this becomes very, very similar every question. It's just there's learning different tricks on the way to solving. It's greatest common factors, factors using trinomials. What you're going to see on this last page we're going to do is using some of the identities to help yourself out. So take a look at question 1. Given that we have been factoring here, typically we move everything to one side. Anyone see an issue with question 1?
You don't have the same signs or the same functions.
I don't have the same function. So even though I have been factoring using sine squareds, the difference between that question and question 3 on the previous page is that this was a cosine squared with a cosine. And then on number 1, it was a sine squared with a sine. I can factor that like a normal trinomial. I can't factor question 1 right here like a normal trinomial. Well, that doesn't mean I'm stuck. Think about your,
Plug in a Pythagorean.
I can use a Pythagorean identity. And that's going to be kind of a trick to this, is that you're never going to be able to change the cosine, the single cosine, but you can always change the squared term, okay? So what you're going to do here in your first step is you are going to make a substitution for your sine squared. I'm going to take out my sine squared, and in place of it, what am I going to put?
1 minus
1 minus cosine squared.
Okay, and that's really going to be the extent of the use of our identities. From here, I'm going to distribute, move everything to one side, and solve. So I'm going to distribute my 2. Because my cosine squared term is on the right and negative, I'm going to go ahead and move everything to the left. So moving everything to the left here, I've got 2 cosine squared plus 3 cosine, and when I subtract that 2 plus 1. Then it's exactly like what we did on the previous page. Factor, solve. So just kind of flying through for the sake of time. I don't want to keep you guys on here too long. That factors into 2 cosine and 1 cosine. Factors of 1 are plus 1 and plus 1. That does add up to 3 in the middle. So I am looking for where is cosine equal to negative 1/2 and where is cosine equal to negative 1. Or, I should say or, excuse me. So for 1/2, my thought process is, if I look at the first quadrant, cosine is equal to 1/2 at what reference angle?
Pi over 3.
Pi over 3. That is not going to be one of my answers only because this is negative. Because that's negative, I know I'm going to get 2 answers, one in quadrant 2, one in quadrant 3 at the pi over 3s. So what's the pi over 3 in quadrant 2?
5 pi over 3? Wait, no.
That one's over in quadrant 4. 2 pi over 3 is in quadrant 2. What's the pi over 3 in quadrant 3?
4 pi over 3?
4 pi over 3. Good. That is then going to exhaust that one. So then my next question is, where is cosine negative 1? In my chart, I see cosine being positive 1. Where?
0.
0. That's not going to be an answer because that's positive. So using the same process, where is cosine going to be negative 1?
Pi.
Good. Any other places cosine is going to be negative 1?
Nope.
Yep. Good. So 3 answers for that one. Last 2 questions we want to talk about. Question 2. Okay, right now question 2 doesn't look anything like question 1. I need to be able to solve this. Considering we've been doing factoring, any thoughts that we could start with on question 2?
Square it.
You could square it. Everyone wants to do that because of the square root of 2. But square root of 2 is in a lot of our answers, like root 2 over 2 and stuff like that. So I don't always care to do that.
You change the cotangent to something? Like,
I would start with that because just like question 1, where you have a cosine and a sine squared, I have a cotangent and a cosine. So that's not real pleasant right now. So what, using your trig identities, what would you change your cotangent into?
Well, it's not. Oh, I see.
Cotangent should be,
cosine over sine, right?
yep, and I would do cosine over sine rather than 1 over tangent because just like proofs, that has something to do with something else in the problem. Now, just like the question back, the second question on the previous page, this is one where even though it doesn't have a squared in it or anything, I am going to move everything to one side to see if I can factor using greatest common factors. What is my greatest common factor here?
Cosine.
Cosine. If I pull out a cosine from each one, what's going to be left in the first term?
1 over sine.
1 over sine, which you can leave it as 1 over sine, or if you're more comfortable, you can change it into,
Cosecant.
Cosecant.
it's up to you. If you change it into a cosecant because you don't like the fraction, that's fine. Just keep in mind that you're going to have to change it back into a sine to find the answers. So sometimes that's adding more work unless it really frustrates you to have the fraction. In the second term, what's going to be left?
Root 2.
Root 2. And once you've factored in any form, I would then set your factors equal to 0. So we're looking for where is cosine equal to 0. That one's easy. We've got to do some work on this one. Okay. So if I set that equal to 0, that gives me 1 over sine is equal to root 2. Because I have to change this into a sign anyway to solve, do y'all know the trick of just flipping both sides?
No, I don't think so.
It's legal algebraically. It's essentially cross multiplying and then dividing, and it saves you a step. So I can literally take both sides and flip them, making this sign and making this 1 over root 2. That's a legal thing to do. It saves you a couple steps. And then is that something I recognize in terms of sign?
Could you multiply by root 2 on the top and bottom?
Yep. So even though it's not something I recognize, and even though I don't make you multiply by root 2 top and bottom, I would definitely do it in this case to make sure. Oh, yes, I do recognize that in terms of sign. So kind of rolling through my answers, I would first look at where is cosine equal to 0. So looking at my chart, cosine is equal to 0 where?
Pi over 2.
Pi over 2, which means it's also going to be equal to 0 where else?
3 pi.
3 pi over 2.
3 pi over 2, because 0 can't change signs, it's both of them. Sine is equal to root 2 over 2, because it's positive. One answer is going to be in my chart. What is that one?
Pi over 4.
Pi over 4. Sine is also positive in what other quadrant?
3 pi over 4 in the second.
Over 4 in the second quadrant. Good. What you're going to start to see is the more that you practice with the chart and the unit circle, the more that these are just going to get into your head. There's only so many different answers that we can see. Like in terms of sine and cosine, you're only going to see 0, 1/2, root 2 over 2, root 3 over 2, and 1. And tangent, there's only a few as well. So the more you practice with this, the faster you're going to get at this. As I always try to remind some of the people, if you're going to do AB calculus, you need to be thinking just chart, but start getting the unit circle and the reference angles in your head. If you're BC, you probably need to just be pulling this out of your head by the end of this unit at least. That's kind of the goal. Question 3 is our last one, and it's a great one for the sake of those that love to just manipulate and do work. Anyone see anything we can replace in question 3? We're all kind of just staring at it right now.
Can we replace sine to be tangent x times cosine x?
Good. Now, it's funny how some of you are picking those things up because that's never something I would have taught. But like Shay, I've seen you do that multiple times and it's made several things easier. So what she is thinking in this one, let me just show those of you that didn't think this. She is saying if I make tangent, or did you say cosine or sine? Sine over cosine.
Sine, yeah, for sine.
Sine is the same as tangent times cosine. Well, how is she figuring that out? Thinking about tangent as sine over cosine, technically what would happen with the cosines? They would cancel and leave you sine. So she is manipulating that kind of backwards to make her have a common, greatest common factor. That is one way to do it, and that is totally fine. Then you can factor out a cosine and solve from there. I have actually never once done that problem that way in 5 years of teaching this. But I like that method. It's good ways to think about different things. You're going to get the same answers as I will. Second way that you can do this involves no manipulation. If I move the cosine to the other side, what question is this asking me?
Where do they equal the same thing?
Where do sine and cosine equal the same thing? Look in your chart. Where does that happen?
Pi over 4.
Pi over 4, and it's going to happen one other place because sine and cosine are both positive in quadrant 1. They are both negative in which quadrant?
Quadrant 3.
3. So where's the other place that this is going to happen?
5 pi over 4.
5 pi over 4. Just for the sake of argument, I want to finish out that other way real quick. If I replace sine with tangent times cosine, I want to make sure I get the same answers. I think we might have to toss a couple answers on this one. If I factor this and solve it, I'm looking for where is cosine equal to 0. And I'll tell you why you have to toss some answers so that this makes sense to you. Where is tangent equal to 1? tangent equal to 1, that happens at the pi over 4 and 3 pi over, or 5 pi over 4, excuse me. So that's where we get the same answers. What you're going to run into in this one, cosine being equal to 0, where does that happen?
Pi over 2.
Pi over 2 and 3 pi over 2. Why do we not see those answers in mine over here? It has to do with this representation that you just used, tangent. Tangent is essentially sine over cosine, which is fine to use, but when you are solving, what are you not allowed to have on the bottom of a fraction?
An x.
Nope. What number?
0.
0. And that's what we have right here. So that is why these answers, if you solved it the second way, you would have to toss them, because cosine is equaling 0 on the bottom. You're not allowed to have that. That essentially makes your tangent undefined, which makes that unsolvable right there. So that's my only issue with that second way of solving. It's not wrong. You would just have to toss some of your answers because you can't have 0 on the bottom of a fraction, if that makes sense. Yeah. But, all right. So that is what I have for today. Thanks for sticking with me for so long. I know we've been here almost an hour now. Homework is on the following pages. Check my PCA for that. I think I did say 1 through 12 here. Don't continue after 12. And then it is on page 252 and 253, go 1 through 9. So it's about 21 problems on these. This is honestly, today is where you start to get really comfortable with finding answers in your chart and unit circle, which is why there's a little bit more on the homework side. This is also very similar to the quiz that is on Thursday, Friday. Okay. Any questions for me? Alrighty, then I will